All right. Thanks for the intro. My talk is about empowering teams through platform engineering, a tale of transformation. I'm Chris Breish. Nice to meet y'all who I haven't met and see some familiar faces again. This is my first time giving this particular presentation, so I haven't been through a bunch of feedback cycles with it. If I'm going through this and something doesn't make sense, or you have a question, you want clarification or whatever, feel free to raise your hand or just yell out and interrupt me. Happy to talk through anything you see here. So who I am, I've been writing software since about 2005. Done a bunch of different languages and technologies and all that. And then I've been leaning towards helping bridge the gap between dev and ops since about 2015, getting into like CI/CD and deployment and that stuff. For me personally, I'm a jet ski enthusiast, and as Joe and I talked about a couple minutes ago, I was a volunteer firefighter for about 10 years. So like after the talk, if you want to get me talking for the rest of the evening, you can ask me questions about that. And if you're wondering what jet skiing in Michigan in the fall looks like, there's a picture of me jet skiing a couple weeks ago. So during today's presentation, I'll be taking you on a journey. We'll be weaving back and forth between my experience with a particular company, and then talking about concepts and principles and things that I think are important for platform engineering. The story that I referenced throughout this took place over about 5 years. If you look closely at the fingers of the people in the photos and stuff in my presentation, you'll notice I used AI to generate all of them. So the setting for the story is a financial services company, had a few hundred employees, and the software engineering department specifically was about 30 people. And for whoever just asked in chat if this is going to be on YouTube, it will be.
Ah, poop.
So the before picture, before I was brought in to make changes, there was a team called the DevOps team. The sort of standard operating procedure to get software from the hands of engineers into running code was throw it over the wall. So engineering teams wrote code, they threw it over the wall to the DevOps team. The DevOps team ran the code. So this is a pattern I've seen at a bunch of places, and I think the best way to describe the problem that it causes is misaligned incentives. Specifically, your development teams, and for clarification, I use developer, engineer, dev, all those interchangeably. They don't mean different things to me. But yeah, misaligned incentives. The dev teams are incentivized to release features, and the operations team are incentivized to have stability. These are opposing incentives. So this is where we were before I joined. Now to talk about some important sort of principles about platform engineering. I think in order to get into platform engineering, there's a prerequisite, and that is actual DevOps, meaning the combination of development and operations into a single team, or single teams. And this is this is designed to align incentives so that the team writing the features is also the team making the system stable. I don't think this has anything to do with tools. If somebody says, yeah, we do DevOps, we use GitHub Actions or Ansible or whatever, but like those things don't make sense to me. I think DevOps is a philosophy and ultimately about assigning responsibility to teams and nothing to do with tools. And I think if a company has a team called the DevOps team, it normally means they're not doing DevOps, in my experience. Specifically, if there's a separate team that builds the software versus operates the software, I think your DevOps team is really an ops team with a confusing name. So you're deciding you want to implement DevOps. You want your development teams to also operate the software they're building. These are some challenges you're going to run into. Cognitive load is one of them. Yesterday you're asking your engineers, add a feature to the web, add a button to the website. And now today you're asking them, add a button to the website, deploy the website, monitor it, make sure you know when things break, make sure the uptime is sufficient, all of that. So cognitive load can go way up. Inclination. Some people just aren't interested in working in this paradigm. Some people just want to focus on adding the button to the web page, which of course is fine and totally valid. But somebody with who leans that way may not be interested in being successful in the type of organization that is going towards DevOps. The other challenge is definitely skill set. There's a bunch of skills. Again, yesterday they're adding a button, and today they're doing all sorts of potentially new things. Your engineer skill set can be a challenge. Specifically, some of the things that I've seen software engineers lack experience in. Of course, not all of them. A lot of people have some experience in some or all of these things. But in general, I think these are important things to keep in mind for folks. CI/CD. So like, how do you take code that's been committed into a repository and make sure that it's going to work and then run it? Logging. How do we know what our system is doing at any time, or how do we know when it's doing something we don't want it to do? Monitoring. How do we know it's working right now? How do we know the website is still up? Alerting. How does our system tell us when there's a problem? And then postmortems, which I definitely think could be, it's a whole specialty that is worth probably its own talk to dive into and talk about. They're so important. there was a problem with our system. We fixed the problem. We're back to business as usual. Let's talk about the problem and figure out what happened and how do we avoid the problem going forward. So back to the story. I was brought in. There was the DevOps team. I was put in charge of a new team. We called it the platform team. It consisted of myself and 2 other people. The organization shifted to a philosophy of you build it, you own it, and you run it. And that's that transition to DevOps that I was talking about. And so that means that engineering teams are now responsible for the entire life cycle of their application. The platform team itself is responsible for making other teams successful in this new paradigm.
Chris, I have a question, and I know that from the experience, there was a lot of that kind of like pushback that you were talking to about on the other slide around the you build it, you own it, part of it, right?
Yeah.
Can you just tell a little bit about how, that message was relayed and, what the challenges were?
Yeah. So rolling out you build it, you own it was done from basically leadership in the software engineering department came and said, this is the new way that things are happening. There may be a way to do a more grassroots thing for people that aren't in a leadership position or aligned with leadership in that way. But what I experienced was a top down. This is the way we're moving forward. A lot of people were on board with, I think, just trying something new that wasn't the old throw it over the wall thing because of the problems that caused with, you have a new feature to roll out, and then you have to make a ticket and give it to the DevOps team. The DevOps team has 4,000 things they're working on. So, it gets prioritized and like, okay, we'll release your thing in 2 weeks or whatever. 2 weeks comes and like something comes up, and then the ticket comes back to you with a problem. And, that it was a huge hassle for folks. So just switching to something new, I think people were excited to try something. However, not everyone was excited about being responsible now for a bunch of new things. I think some of it is, it's intimidating. Oh, now you want me to learn Docker and orchestration and logging and monitoring, alerting, metrics, all this stuff. Some people are just intimidated, and it it took some support of those folks to get through the uncertainty of that time. But once we were through it, people, some of those people loved the new paradigm, and it worked really well for them. Other people never bought in, never liked it. I talked about inclination before. Some people just they want to be experts in their one corner of the world, and they don't want to be bothered with thinking about all the other stuff. And there's definitely a place for that, but it was a challenge in this context.
Thanks.
Yep. So, what is a platform? It's I like to think of it first as a product designed to provide functionality to other teams. Those teams normally are internal to the company. But you look at a company like AWS or whatever, and they offer their sort of platform. I mean, AWS itself is a platform with many layers built on top of each other that they offer to the public. I don't think most companies are doing that move, but it is a move. A platform is designed to reduce cognitive load. To try to reduce the number of things engineering teams have to worry about on a day-to-day basis, or the decisions that they have to make in order to release the features they're trying to release. I think a platform is competitive, meaning if you have a platform to provide VMs to other teams, like ultimately you're competing with AWS and Azure and DigitalOcean and et cetera, et cetera, et cetera. So like I think for the teams building a platform, they need to think in terms of being competitive. Not to a broad audience, not to the entire world, but to the people in their company. And speaking of that, the platforms are built from a company's perspective, so they need to meet the specific needs of the company. So if your company is doing a bunch of highly parallel processing that needs a million cores to work, well, the platform that you build should support that use case and make it easy. If your company is just building a bunch of marketing sites, then the platform should be built to make that use case easy. And the advantage that an internal team has over an AWS or an Azure or whoever is they can know the needs of the company, the needs of the other team, and meet them, and a lot of times meet them before folks know how to clearly define the problems they're having. So the approach that we took to implement, or the sort of what our team did, two-prong approach. The first was build and operate platforms that solved shared development concerns. So every team needs a place to store their code. Every team needs a place to run their pipelines. Most teams need a place to run their web service or website. Every team needed to monitor the uptime and what performance of their applications. So like those are the platforms that we were building. The other prong of the approach was enablement. And this is a term I borrowed from the Team Topologies book, along with the platform term. I think I use it in a way that's aligned with that book. But so enablement is helping folks learn the skills to be successful. In our case, be successful in the you build it, you own it world. So teaching people how to do logging properly, teaching them how to do postmortems and monitoring and alerting and all that. Teaching them what a Docker is. The principles that we operated by First and foremost is user empathy. You have to care about the people you're building things for. And if you care about it, you have to understand it. So you have to take time speaking with people, understanding the problems they're trying to solve, understanding the problems they're having, and then building platforms to support them. Without empathy, I don't think you can have a successful platform. A product mindset. This is the same as you hear used more broadly in the industry. Like, you think about the problems your users have and how you can help solve those problems. Like, you don't. It's not effective to deliver a Kubernetes. It's effective to deliver a place for engineers and your organization to run their code reliably. It's which might use Kubernetes, but it's a different way of thinking about what you're doing. The next three are sort of three sides of the same three-sided coin. Stay out of the way, meaning don't be in people's path to production. This goes back to like the DevOps team where you had to ask permission or ask somebody else to push the button for you to deliver your software to production. It was our goal to never be on a team's path to production, never need to be standing by while they're releasing code, that sort of thing. Being available if they needed us, but that they didn't need us to push a button. Self-service, rather than needing to submit a ticket or fill out a form in triplicate or any of that. They can just go and get the things that they need themselves when possible. And then finally, teach a person to fish. I think this is something that like we had to work on within the team a lot, because I think ultimately one of the things that drives people into like DevOpsy or platformy work is, first off, you're technically minded, but secondly, you like to help people and you like to see the smile on their face or feel the relief that they feel when you're solving problems for them. And oftentimes what this pushes people to do is somebody would come to us with a problem and our natural inclination would be to like solve it for them. But this ultimately causes dependencies between teams where like now if that thing that we built for them needs to change, they need to come back to us and we need to be involved in updating it rather than sitting with them, teaching them how to build the thing that they need, and not having a dependency between teams.
Chris, on that one, can I ask, and it might be later on in slides, but what form did that take? Was that, was that something that you guys had structure around, or would it depend on the team?
I mean, it definitely tried to individualize, did a fair amount of pair programming and I know there's different ways to do that. One of them might be or pair programming or mobbing where you have a timer and switch back and forth. But I liked in an instance where one person has most of the knowledge, most of like the technical know-how to do a thing, and one person was lacking that and maybe knew the problem better or whatever, I would want the person that didn't have the technical knowledge to be on the keyboard most, if not the whole time, so they can be learning the technical skills through that session. We also did the occasional presentation. We did for commonly asked questions, we would do wiki articles and things like that. To name check Dan here, Dan put together a wonderful boot camp for onboarding people onto a Kubernetes platform. That basically depending on the topic and the team in the audience, we would vary how we actually carry this out.
Yeah, that makes sense. Thanks.
Yep. So for the previous slide was the platform team's principles that we operated by. This is more organizational principles that I think are important to make this paradigm work. The first one being, of course, you build it, you own it, like we've talked about in previous slides. Also, the people closest to the problem should be the ones making decisions on how to solve the problem. In the title, I talk about empowerment, and this is you build it, you own it, and this closest people principle are all about empowerment. I don't think it works when a leadership says you're empowered to do whatever you want as long as you use our platform and follow these rules and follow the style guide and use tabs rather than spaces and all that. It's really about pushing power down into the engineering teams. Not prohibited, not supported, meaning I alluded to it a little bit in the previous point. Teams are allowed to solve the problems they have their own way. They can experiment, and they're not forced down a particular path. If there's a platform team that makes a platform that doesn't meet any of their needs, maybe they're the one team doing highly parallel work and every other team is doing the marketing pages. You don't want to prevent that team from finding a solution that works good in their use cases. And then finally, with great power comes great responsibility. So you're giving engineering teams freedom to operate within their expertise, to do experiments, to solve problems for themselves. But your expectation of those teams should be that they are being mindful of the organization's needs around security and compliance and cost and like availability. And it's not okay for one person on a team to say, like, I want to use this database technology nobody's ever heard of, so they run this one database thing, nobody else knows anything about it. They didn't bother to follow any of InfoSec's policies around how to secure things. It's important that teams are held responsible for the decisions that they're making in this paradigm. So some lessons that I learned through this journey. It's hard. It's hard to live in the you build it, you own it world, both from the platform perspective and from the engineer's perspective. And I think the simple truth is that not everyone is capable of working in that paradigm. or at least capable, perhaps in the place that they are in their career and life at the time. Secondly, not everyone wants to participate and work in that paradigm, which is also, is fine. Cognitive load has to be aggressively managed. It was probably one of the things that we struggled with the most. And for the folks who have worked with Kubernetes, like, you'll understand what I mean by cognitive load. There's a ton that you have to know, and it's hard. Certainly not impossible, but that cognitive load has to be aggressively managed, both from the a platform team has to manage it for their customers, and then leadership has to manage it for their engineering teams. Hiring is a challenge, and that's both hiring engineers to work on these small empowered teams. That's hiring folks for your platform team. That's hiring effective leaders. All of that. It's a challenge to hire in general. And speaking of hiring platform engineers, I just read an article today that over the past quarter, folks with the title platform engineer demand 20% more salary than folks that have a DevOps title, which I thought was interesting. Even though to a lot of companies, they're probably a similar role. So after I was there for 5 years, the software engineering org doubled to about 60 people. We had 5 members on the platform team, and the platform team, in an effort to manage our own internal cognitive load, we divided responsibilities. And in our case, the seam that we drew was one team we called compute, or sub team really. We called compute, which was in charge of the platforms that ran other team software, so Docker Swarm and Kubernetes mostly. And then the other sub team was cloud management, which was getting teams onboarded into the multiple clouds that we had access to, and teaching teams how to use the cloud and how to worry about cost and all of that. So I hope the presentation highlighted some ways that you can think about DevOps and platform engineering and what they are. I hope it drew attention to some principles that I think are important for being successful in the paradigm, and I also hope it helped illuminate some problems that you might anticipate if you decide to go down this journey. Happy to take any questions or comments at this point.
Chris, you said that you had borrowed a couple of words from the Team Topologies book, and
Yep.
and that it resonated for you, and what you did felt fairly consistent. In what ways do you feel like you diverged from the Team Topologies framework, outline, whatever that is?
Yeah. I mean, I think in our case, this particular company, the platform concept, there was one platform team, and really, I think platform is a bigger concept than that. I think, your infrastructure folks I don't think this is being talked about in sort of modern discussions about it, but your infrastructure folks are providing a platform. They're providing Active Directory to manage users that can be logged in as and passwords rotated and all that stuff. Maybe they're providing compute resources in a data center, that sort of thing. I don't think it's a far stretch to include teams like legal and HR as platform style teams where they're trying to help other teams understand what benefits are available to them and how to maintain healthy mental health habits at work, that sort of thing. At the other type of team that I didn't mention at all during this talk, well, there's two. There's stream-aligned teams, and like in the talk when I'm talking about engineering teams or dev teams, that I'm normally meaning stream-aligned teams, and then complicated subsystem teams. And I struggle with the concept of what exactly a complicated subsystem team is versus a platform or stream-aligned team. I'm not sure I see the distinction, but stream-aligned teams, one of the ways that we sort of deviated was, I think it's really hard to align when you have legacy systems that don't have strong seams between business units. It's really hard to have an engineering team that's just is aligned with one business stream. A lot of times they'll be aligned with one mainly and like a little bit of another one, but that sort of thing. So I think our this company's implementation strayed from the book in that way. And over time you get better. You learn like where you pick I think these are two different things, and then like later on the business decides no, that's actually one thing, and you have to recombine, or you think it's one thing and now it actually is two different things, or like it's definitely not okay, now we're stream aligned, these are our 5 streams and that's what it's going to be forever. It's definitely there's experimentation, and you got to figure out what works for the company. Does that answer your question?
Yeah, thank you.
Yeah, you're welcome.
So, hi, Chris. This is David.
Hi.
So I'm not familiar with the Team Topologies. It does sound interesting, but in a highly regulated industry, so I work in the insurance industry, right, where I don't know if I'm on the path to, implementing CI/CD. I don't know if the internal audit team would allow my engineers to deploy, right, their code themselves. Have you been in that type of environment before, and any suggestions on how to approach that?
In some ways, yes. In some ways, no. I don't know that I've been in something as highly regulated as that. I've definitely been in places where audit teams have drawn lines in the sand around particular solutions rather than focusing on the problems that they have. And let me elaborate on that. Like, I've heard people say, well, in order to deploy code to production, you have to put a ticket in to our ticketing system so that we have a record of this request to go to production. So they say you have to put a ticket in. But But if you talk to them long enough, what you'll find out is what they actually need is not a ticket in Jira, but they need a record of that request that this thing went into production, and they need the approval of a certain role or responsibility. And I think you can build your CI/CD in a way that meets those needs. You can say, a team lead or whoever has to push the go button. But it's, literally all they have to do is sign into the CI/CD process and hit the go button, and the rest of it takes over.
Yeah, I've actually done CI/CD in a few different regulated industries, and I think one of the things that helped us with the auditors was working in, whether you want to call it ensembles or mob programming or whatever you want to call it, but so it's not one individual developer that can commit a change that goes all the way into production. But if the way that you get, if there's rules around how the team works, right, that no single person works on production code by themselves, that was a way that we were able to deal with that, like that a different team has to deploy a change from the development team. So that was, we were able to do that specifically there were two different industries, and that seemed to pass muster with the auditors.
Yeah,
Okay,
and
yeah.
one other thing that I think a CI/CD pipeline leads to is that you don't have individuals, you lessen the amount of individuals that need access to production because the code is being deployed by CI/CD modules, which, that gets a lot of thumbs up around the auditors and the people that are requesting for those tickets, right? You're leading towards a place where machines are deploying code into production and not people, which, is a much better space.
Yeah, no, agreed. Yes, thank you.
Yeah, the key is find out what the requirements are, and talk about those things and how to solve meet those requirements, rather than focusing on the solutions that are perhaps in place today.
Okay. And then yes, another question, right? So in my org today, currently, right, when we deploy changes to the database, they're all performed by DBAs. How do you get DBAs comfortable that you have these processes that are going to push changes to the databases themselves? Is there like a, pre-review process that gets them comfortable?
Yeah. There's a couple strategies I would use there. Number one, all database changes should be captured in source control and scripted. I think that's a prerequisite, and that's something like, if your DBAs aren't doing that today, they can do that. They can do that tomorrow. And, it's a skills thing; they have to learn how to do it. But yeah, and Anthony says Flyway is a good open source tool for that. Secondly, finding seams in the database and allowing teams to own the data for their specific application, I think is a good strategy. A lot of times organizations build one giant monolith. All of the data for the whole organization goes into a single database or database server or whatever. And at a certain point, that fails to scale any farther. All of your teams are now tied into this one database. It's very dangerous and expensive to make changes to the schema or to the data or how the data is used. So finding like who actually needs this data, and if it's just one small corner of the organization, give them that data in its own silo rather than in the silo of the whole org. And that maneuver is a journey. I talk about it in a 30-second blurb, but that's a journey that will likely take years. In the meantime, for changes that need to be made to that shared ownership or joint ownership data, if you're doing your scripted database deploys, like I mentioned, you can take more of a inner source model where your DBA team owns the repository with those scripts in it, but other teams can come in and submit merge requests or pull requests into that repo, which gives the DBAs the ability to review changes and all of that. I think it's a good model for things that you would ideally like to be able to empower your teams to do, but maybe you can't do it yet. You still need a team with some central control on it.
Yeah, thank you.
One of the places that we did that maneuver is for DNS records. So my team centrally managed DNS records, but a bunch of teams, they would need to spin up a new application. They need a new DNS record. They would just submit a pull request to our repo, and with the changes they need it, we would take a look at it, make sure it looks good, and hit the go button for them.
Yeah, I mean, it makes sense. All it takes is an extra space, and it doesn't work.
Right. Yep. All right. Anybody else? If you think of something later and want to reach out, you can reach out to me on LinkedIn, or if you want to get a hold of me, the Anthony's know how to get a hold of me too. Happy to talk about this stuff. I love talking about it, and can talk about it for hours. If you or your company need help with your own platform engineering journey, I'm also interested in talking about that.
Awesome. Thanks so much,
Thank
Chris.
you. Thank you.
Yeah, thanks everyone for showing up and participating.
Yeah,
And I guess when it gets uploaded, Anthony will drop a note on the XP page.
yeah. So I'll reply. So on Meetup, there is a page for this talk, and there's comments there. So I'll just post. I'll post a link to it in the comments when I have it up there. Awesome.
so
Thank
much.
you, Chris. I appreciate the talk today.
Yeah, no problem.
All right. Take care,
See ya.
everybody.
Take care.